Good evening, good day, and assalamu alaikum wa rahmatullahi wa barakatuh. Here we start our example 2 for lab 3, where in the last example we implement the hub as we can see in our source in the device. This is how we implemented the last time, and then we connect all the nodes in our network using a hub, as we can see here. Okay, the last example implement the hub. However, the delay, we make a fixed delay inside each host, like a delay 35 millisecond. However, the requirement of example 2 is to implement the link delay, and as we said the last time, this one will be implemented in the MAC layer by creating a send delayed. Instead of sending the bucket directly, we send a delay by causing a delay at a value of something. Then let's see how to implement that. Okay, we go in our data link layer and we see the MAC layer, and that is what I'm talking about here. In this send, instead of send, we need to send the data with a delay. So instead of send, we send delayed. The send delayed function, okay, takes the message, the delay time, message itself, delay time, and the gate with the index. So here we need to add another one here, and let's say here our delay is equal to 3.5. So this is another fixed delay. However, the example that we are trying to implement here is not implementing a fixed delay. So to do that, we need to add change many C code inside. So for example, each bucket must have a size, okay, and then our channel must have a data rate before we can implement the delay. The bucket size, normally the application layer, when we create our bucket here in the application layer, okay, the bucket itself must contain a data size, not this data size, but we need to implement that one like a byte length. Okay, to do so we need to have in our NED file another configuration parameter here to get the delay, to get the bucket size. So let's say we have here integer bucket size. Okay, I just put any default value. Let's say the bucket size equal to 1024, that is 24 byte. Okay, then we can rewrite this one from the ini file. Okay, then this one here must be read by the application layer. So we declare in the application header, we need to declare the bucket size. So we need to have here another integer here and give it the name bucket size. This parameter we read it at the initialization. So when the node start up or the application layer start up, we need to read this one at the variable. So we need to have here our bucket size. Okay, let me check the name of the variable. Yeah, it's a bucket size, bucket underscore size, and this one we need to read it at the bar. Okay, how we read it from the NED file, and I think the name is bucket underscore size, and I believe this one is supposed to be casted into integer. So let's just check if the things are running correctly, the names are correct or not. I'm just doing control B to build the whole thing to see if we have any mistake in the in the type error, like spelling or something like that. So it looks like nice here, the bucket size and bucket size. Okay, then once we create our bucket here, we need to set that one in the data. So in our data, so we need to set the byte length, set our byte length. Okay, so now our byte length is supposed to be that number, which is the bucket size. exactly this integer. Okay, so now we already put our byte length here. Okay, and the bucket size supposed to be the bucket size plus the header. However, now let's just ignore the header. Okay, the application layer will send the data, we send data to the transport layer, so the transport layer as well need to implement that bucket size. So let's just put a fixed number here when we receive it from the application. So before we send it out, we need to set the bucket size of the transport layer here. I think we give it the name bucket. So this bucket we also need to set byte length. This one here is supposed to be the size of the header, so we assume it is 32 byte header of the transport layer. Okay, once that one is done, so we go for our MAC layer, the MAC layer as well. When we receive from the transport layer, so I'm just going here from the transport layer here where we receive at handle message. Okay, the MAC layer as well, when we create the bucket, okay, the frame, so the frame must have what size before we encapsulate the bucket. So the frame itself, the frame must have size. So let's just put the side of that one, which is supposed to be the what, the head of that one. To set the byte length, let's say we have 32 byte, that is the size of the header. So now if we assume that the bucket that we create is 1k 1k 1 kilobyte plus 32 per 2, that is 64 byte. So 1024 plus 62, that will be the total size of our bucket. So now to send the bucket outside here, this one is supposed to be not just a fixed number, it's supposed to be something, and the number here is supposed to be depend on the channel, the channel bit rate beside the bucket size. Okay, so to do so, we need to find here the byte length of the frame here. Okay, let just I will declare to integer here. First integer here is a data size, which is equal to exactly just the frame after we encapsulate it, the frame dot get byte length. Okay, now we need to know the bit rate of the channel. The channel, uh, to read the channel, the channel, uh, we need to read it from the message, or we need to find one of the gate that connected to the, what do you call it, that the gate that is connected to the MAC layer. Okay, to do so, so firstly we need to declare a C channel data array channel. Okay, we need to have a pointer refer to the channel that we are connected to. Okay, and this channel is supposed to be actually in the parent model of our node, because we need to go to the node. Okay, and inside the node we need to find the gate with a specific name, and I believe that the gate that we are talking about is what we give it the name what, out. Okay, and each gate must have an index, otherwise it won't work. Okay, then we need to get our channel. Okay, this is a channel. Sorry, you need to refer to the things inside the channel. Get channel. So once we get the channel, I believe that the last things we need to do here is we need to cast all this one into that array channel. So this one we need to add the check and cast. check and cast. So we need to check our things here, and we need to get in the C data region, and this is supposed to be a pointer. Let's check if the things is correct, or I missed out put something inside the code. I believe I missed something. Oh yeah, I think that the I is not here, so we're supposed to add this one inside our delete. Yeah. Because the I is important here, so this is the channel that we are looking for. So here it's supposed to be perfectly. Yeah, this one happened because the I, which is the index of the gate, output gate. Okay, build it. See, check and cast. Okay, so now our data rate channel is correctly, perfectly, we have it here. Then we need to find the data rate channel of this one. Let's say I have any double variable, double variable, and let's say data rate channel rate. This one is equal to the channel, so we just need to find inside the channel, we need to find out the data rate, get data rate. So now we are reading our data rate inside the channel. Okay, so once we get the data rate channel, now we need to calculate the delay. The delay, I know it is just now, it is just a relation between the data size and the data rate, and it's supposed to be the data size divided by data rate. So now our delay, let's say we have any another table. Our delay is equal to, let's just give it the name propagation. Delay is equal to the bucket size, which is the data size, divided by data rate. So now this is our propagation delay, or let's say transmission delay, not propagation delay, sorry, transmission delay. So our transmission delay is equal to data size divided by data rate. So now we need to find our this one, and instead of sending with that delay, so now we are sending with what exactly the delay that caused by one bucket to go. Let's build it, see if I make any mistake again. It looks nice. So now we have our this one. Okay, perfectly. So now we have we firstly to implement the delay, just to go back the things one by one. Firstly, we add the data size for each packet that is generated, and we say this one here we need to specify it from line I file the application. Okay, so that means each bucket must have size. This size we add it to the generated bucket in the application cc at the handle message. So when we generate the bucket, we add the data size, we read it here we read it from the ned file, because we declare our parameter, and then we read it from the ned file. Then whenever there is a bucket is created, we add a size at the byte length, because this one is the one that used by the simulator, by the channel, to cause the delay. Okay, once this one is done, then what we do, the next thing is, yeah, because the application layer sent to the transport layer, so we need to go to the transport layer and add that parameter. So now here the byte length, of the transport layer is equal to 32. We assume is equal to 32 byte, which is the header of the transport layer. The last thing that we do is what, add the data link layer. So we add the delay at firstly we add the frame size, the frame header. Then when we encapsulate it, actually the new size of the frame is equal to the current frame size plus the size of the encapsulated bucket, which is the one that we are getting from the upper layer. Okay, once this one done here, so now we need to find the data size of the bucket of the frame. So now the frame that we are intending to send, we get the data size, and for each channel that is corrected, it is connected to the now, or we are sending right now exactly. So what we do is we read the channel, because we need to find out the data rate channel that we implement inside the channel. Then the transmission delay is equal to the data size divided by the data rate. So now we send delay with the transmission delay. So this one will implement what the delay inside the channel. This one here will require us to change our network here, the hub network. Instead of just putting a delay, now we need to put what, a data rate channel, or we need to put the data rate of the channel. So here if I said data rate is equal to 1 megabit per second, that is supposed to be the data rate of my channel, and this is will become like the propagation delay, which is exactly means what, means the time required to send one bit from one end of the link to the other one end of the link. This one here, it depends on the length of the link and the propagation speed, or the transmission of the bit speed. So as we said in the lab the last time, in the fiber optic, this one is equal to speed of light. Okay, so it's related to the speed of light plus and the link, the link, the length of the link. Okay, and data rate is equal to, it depends from one type of link to another one, and exactly means the data rate. So now here what I will do is I will add my data rate and delay, assuming that the delay, the propagation delay is fixed. That means all the links have the same length, and all of them, they are of the same type. Okay, so now I add my delay again, add my delay here again. Okay, my bit rate. So now I'm assuming that this link is sending with 1 megabit per second. So now let me, I change my things here. So this is the application start time. I will change the what, the bucket size. So for each node I will create a different bucket size. So let's say here for node 1 dot application layer dot bucket size. Okay, I said that I will say node 1 will generate a traffic of 1024 pi. Okay, node 2, the bucket is bigger, node 3, node 4. So node 2, the bucket is 512 pi. Node 3, let's say the bucket size is something like 2048 2k, and node 4 generate bucket, let's say the bucket size is 128 pi. It's very small bucket. So now I want to run my simulation and see if the things are running nice or not. So this my simulation is running. So I will run the simulation for 100 seconds and just calculate the logic. So now if I close this one and go see my result, okay, now I will see there is different delay. Here we have a mean delay, we have a mean delay, because the bucket size sent by this one and sent by this one are not the same. Just to make it nicer more than this one, so here I will go for my network, the hub network here. Okay, and in the I will make each one of them send it to a different link. So let's say node 1 is sending where is it? Here, sorry, the destination. So node 1 is sending to node 2, node 2 is sending to node 3, node 3 is sending to node 4, and node 4 is sending to node 1 back again. So now I'm very sure that each one of them is sending a different one. So let's see if the delay is still the same or not. It's supposed to have different delay because the delay now is totally depending on the bucket size. So I run for 100 seconds. Now I open my result just to see if the things are nice or not. So now if you see here, the delay at node 1 is 0.07, at node 2 is 0.88, and at node 3 is 0.79, and at node 4 is 0.102. And I believe this one is receiving the big the largest packet. Yeah, a little bit smaller, little bit smaller, here a little bit smaller. So now we create our thing, and the delay is implemented. Okay, and we have now the student are supposed to solve the task one. Task one is all the link are, we are just changing the links, and we are testing our network when we have a different type of links, and exactly here. And so the student are supposed to calculate based on the given distance. Okay, and the link type to calculate the propagation delay. However, the processing delay is supposed just to follow up the example. Okay, task 2 is analytical, so that means here we just change the number of nodes, okay, from 10, 15, 20, 25, and 30, and every time we calculate the average delay. Then we draw a graph for the delay, that the obtained delay, and to see if that the thing is affecting the delay or not. And thank you, and see you in the next video.